All right, today we're going to talk about 12.5, and this is going to be the last section that we're going to cover for sequence and series. Today we're going to talk about something called recursive rules. Okay, and recursive rules are going to be a little bit different than what we've seen the last couple days, but we are still going to be using the arithmetic and the geometric. Okay, so we're going to still use those two concepts, but now we're going to apply them to something called the recursive rules. Now, first thing, explicit is what we've been doing the last couple days. And explicit means there's one equation, okay? And the two examples for that are right here. This would be our explicit for arithmetic, and this one here would be our explicit for geometric. Now, one equation for the entire sequence. That's explicit. Today we're going to talk about recursive, like I said, and recursive is when you have multiple equations. Okay, so this as a recursive rule gives the beginning term or terms of the sequence and then a recursive equation that tells a sub n after that. Okay, so we're going to have to start out by defining the beginning term or terms, so one or maybe sometimes more, and then that recursive a sub n comes after those beginning terms. Okay, so again, explicit is when you only have one rule for the entire sequence. Recursive, you're going to have more than one equation to define the sequence. Now, evaluating. Here's two examples. This first one, A, factorial numbers. Here's an example of what one might look like. A sub 0 equals 1. So that's giving you the first term. And if you look down here, that's what it tells you. A sub 0 equals 1. So term 0 is 1. And then this A sub n is giving you the rest of them. Okay, so A sub n gives you everything after 0. And the equation for that is n times a sub n minus 1. So when I look at anything else, you're doing n times a sub n minus 1. Anything after 0, you're using that equation. So when I look at a sub 1, you're putting 1 into n for your equation. So a sub 1 would be 1 times a sub 1 minus 1. Well, what is 1 minus 1? They already did a little shortcut here. 1 minus 1 is 0. So this is n times a sub n minus 1. And again, 1 minus 1 is 0. Then you're going to do a substitution. What is a sub 0? A sub 0 comes from up here. A sub 0 was 1, so you're plugging that in. 1 times 1 is 1. Then you do the same thing for everything on down the line and see what you get. So we have n for a sub 2, we have 2. So n is 2 times a sub 2 minus 1. And 2 minus 1 for this part right here is 1. A sub 1, you know what that is. You already did that just a second ago. A sub 1 was 1. That's what we got for our answer. So we have 2 times 1, which is 2. And then you do the next one, a sub 3. What's a sub 3? Plug that in. Anytime you see an n, plug in a 3. 3 times a sub 3 minus 1. Well, 3 minus 1 is 2. A sub 2 we already found. A sub 2, if we come over, was 2. So this is 3 times 2, which is 6. A sub 4. So anytime you see an n, you put 4. So what's our equation? 4 times a sub 4 minus 1. 4 minus 1 is 3. A sub 3 is 6. So we have 4 times 6 is 24. Okay, so you have a beginning part that is given to you, and that was a sub 0 in this example. And then everything after that, you have to use the a sub n equation, the explicit equation, to find the rest of your terms. Okay, looking at the second one, it's a little bit different, the Fibonacci. And some of you may have heard of Fibonacci before. This is the recursive equation for Fibonacci. Now, if you notice, he gives us a sub 1 is 1, so we wrote that one down. He also gives us a sub 2 is 1. So he gives us 2 terms. After that, he gives us our a sub n. Okay, but we have 2 terms that he's defined for us. And then after that, we're using this equation. So our equation is a sub n minus 2 plus a sub n minus 1. And that's what we're using for 3 and down. Okay, so if we start that with 3, because remember we already got 1 and 2. So if we start that sequence with 3, plug in 3 for n, so a sub 3 minus 2 is 1, plus a sub 3 minus 1 is 2. Well, what's a sub 1? Come back up here. A sub 1 was 1, plus a sub 2. A sub 2 was 1. 1 plus 1 is 2. Now, same thing for 4, except now we're plugging in 4. So put in 4. A sub 4 minus 2. 4 minus 2 is 2, plus a sub 4 minus 1. 4 minus 1 is 3. And again, you already know what these two are. A sub 2, come back up here, is 1. And a sub 3, come back up to 3, was 2. So 1 plus 2 is 3. And then keep going. A sub 5, so n is 5. So plug it in. A sub 5 minus 2, 3, plus a sub 5 minus 1 is 4. A sub 3 we got as a 2, plus a sub 4 we got as a 3. 2 plus 3 is 5. Okay, so that's our examples for recursive. And the directions were first 5 terms. So we stopped at 5 terms. So for the first example, that was 0, 1, 2, 3, and 4. That was term 5. Okay, so since we started with 0, term 4 was it. And the second one we started with 1, so we went 1, 2, 3, 4, 5. Now, factorial is a little extra, and if you want to look at that, you can. Okay, but I'm not going to spend any time on that because we're going to talk about that actually this next week when we start probability. Now, writing a recursive rule. Okay, again, recursive means more than one. Writing a recursive rule for arithmetic. First thing, it tells us it's arithmetic, but even if we didn't see that, hopefully we see this D, and we know D means common difference, so that's arithmetic. So anytime you have a difference or a D, it's arithmetic. Now, 2 things. We need to write an explicit and a recursive. Explicit is just one. Recursive, there's multiple. Okay, so starting with the explicit. So here's our general explicit rule if we have arithmetic. Okay, so what do we need? For our general rule, there were 2 things we need, A1 and D. Well, they give us both of those. So plug them in. A sub 1 is 4, D is 3, and pull your 3 in just like we've done in the past. So this gives me 3n minus 3, which is where we get our 3n, and 4 negative 3 is 1. So this is our explicit rule. Now, they want us to also find recursive. So recursive, there's more than one term. Okay, so start off your recursive by defining your first term. Okay, and they gave us our first term, a sub 1 right here. A sub 1 is 4. So start off always by defining at least that first term. Then the rest of it's going to come from this equation, a sub n minus 1 plus d. Okay, this is going to be your recursive rule when you have arithmetic. And all you have to do to find your recursive rule is to plug in that d. And we knew from up top that d is 3. So the a sub n is a sub n minus 1 plus 3. So the recursive rule has 2 parts to it. A sub 1 is 4. That was the first part we defined. And then a sub n equals a sub n minus 1 plus 3. Okay, so again, explicit, only one equation. Recursive, 2 equations. Now, same concept except we have geometric. Okay, so here's our geometric. And if you didn't notice it was geometric, as it says in the directions, we have an R Again, anytime we see R, we should think of that ratio, and that ratio means it's geometric. Okay, so same two things again. We want explicit and recursive. Explicit is one equation, recursive, multiple equations. Now, first thing, explicit. And again, this comes from what we talked about the other day with geometric. Geometric explicit. Here's our equation. And remember, we needed two things. We needed a sub 1 and we needed r. And we have both of those. A sub 1 is 3, r is 0.1. So all you have to do for that explicit is plug it in. Okay, so there's our explicit rule for geometric. 3 times 0.1 to a power of n minus 1. Now, remember from the other day, we cannot multiply these because the bases are different and the powers are different. So make sure you keep that just like it is. Then our recursive. This is going to be our recursive for our geometric. A sub n equals r times a sub n minus 1. Okay, this is our recursive. This a sub n minus 1 is going to be our consistent section of our recursive equations. So the only thing I need for my recursive equations is this r. Okay, but remember, recursive means more than one. So let's go ahead again and start off by defining our first term. Okay, so we got to go back up here to remember what our first term is. A sub 1 equals 3. So when we're doing our recursive, start by defining that first term. A sub 1 equals 3. Then go into our a sub n. Okay, and what do we say? Here's our recursive for geometric. All we need is r. So our a sub n is 0.1 a sub n minus 1. Now, here's another recursive, and it's not geometric or arithmetic. Okay, so if you have geometric or arithmetic, you're going to use those patterns that we just explained in the last two slides, but it is possible to have a recursive rule that does not follow either one of those patterns. Okay, and this is going to be an example for that. We have a sequence up here, 1, 2, 2, 4, 8, 32. And I want to write a recursive rule for this sequence, but it's not geometric and it's not arithmetic. Because why is it not arithmetic? Plus 1, plus 0, plus 2, plus 4, that does not follow any pattern. So it's not arithmetic. Geometric has to have a ratio. 2 divided by 1 is 2. 2 divided by 2 is 1. Okay, so when you start dividing, they're different. So it's not geometric or arithmetic. Okay, so you have to figure out the pattern and then write the rule from the pattern. Okay, some of you hopefully have already been looking at this, trying to figure out the pattern. What is the pattern as I go from left to right in this sequence? Does anyone see it? We're not adding the same numbers. It's something to do with squaring, with cubing, square roots. What's the pattern? I'll give you a hint. The pattern doesn't start until term 3. Does anyone see it yet? The first two terms we're going to have to define because the pattern does not start till term 3. The pattern is you take the two terms in front and multiply. 1 times 2 is 2. Then take the next two terms. 2 times 2 is 4. Then take the next two terms. 2 times 4 is 8. And take the next two terms. 4 times 8 is 32. Okay, so in order to do this pattern, I have to first know what the first two terms are. So that's the first part of my answer. A sub 1 equals 1 and a sub 2 equals 2. I have to define those two terms in order to write out the rest of my pattern because the rest of my pattern comes from those two terms. Okay, so step 1 is to define those two terms. Then the next part, since again, we're not following geometric or arithmetic, we have to write out this a sub n ourselves. What are we doing to get term 3? What did we do to get term 3? We multiplied term 1 by term 2. Okay, well, how do I write that? Term 3, what did we do? We multiplied term 1 by term 2, right? What do we do to get term 4? Term 4 was right here. We multiplied what two terms together to get term 4? We multiplied term 2 and term 3. Okay, and I could continue going down this line, but I need to figure out, how do I write this as recursive? How do I write this so I can follow the pattern all the way through? If this was a 3, I multiplied it by 1 and 2. So how do I write this? A sub n, what? How do I get a 1 from a 3? N minus 2, and a sub n minus, how do I get a 2 from a 3? N minus 1. So that is the a sub n, that's the recursive part, or the repeating part of our answer. Okay, and what are these telling you to do? This n minus 2 is telling you to go back 2 terms. This n minus 1 is telling you to go back 1 term. So I'm going back 2 terms and multiplying, going back 1 term. Okay, and that is, if it does not follow arithmetic or geometric, you got to find the pattern. Okay, so this was the pattern for this example, and it can be different. This is the pattern for this one. Now, let's look at the next couple. Write the first 5 terms. Okay, so now let's do some examples. Number 15. They give us the first term. Okay, so we write it out. A sub 1 is 4. And then everything after a sub 1 has to follow this pattern. Okay, so after a sub 1, everything else is n plus a sub n minus 1 plus 6. So a sub 2, we're plugging in 2, is going to be 2 plus a sub 2 minus 1 plus 6. Plug it in. Okay, and then you can save yourself some room. What is 2 minus 1? This is a sub 1. And we already have our answer for a sub 1. A sub 1 is 4. So what are we going to write? 2 plus a sub 1 is 4 plus 6. And 2 plus 4 plus 6 is 12. A sub 3, so we're plugging in 3 into all of our n's. So 3 plus a sub 3 minus 1 plus 6. 3 minus 1 is 2. And a sub 2, we're coming back up to a sub 2. What is a sub 2? 12. So 3 plus 12 plus 6 is 21. And then a sub 4, you're plugging in 4 anytime you see that n up here. So 4 plus a sub 4 minus 1 plus 6. 4 minus 1 is 3. A sub 3 was what? A sub 3 was 21. So we have 4 plus 21 plus 6 is 31. And then they want the first 5 terms, so I need one more. So a sub 5, plug in your 5s. 5 plus a sub 5 minus 1 plus 6. 5 minus 1 is 4. A sub 4 we just did. A sub 4 is 31. So 5 plus 31 plus 6 is 42. Okay, let's do 17. 17, they gave us a sub 0. A sub 0 is negative 4, so that's our first answer. And then everything after that comes from this equation, this rule. So we have a sub n equals a sub n minus 1 minus 8. So what's after a sub 0? What's the next thing we're going to plug in? A sub 1. So we're plugging in 1 anytime there's an n. So a sub 1 minus 1 minus 8. 1 minus 1 is 0. So that's a sub 0, which is negative 4. Negative 4 minus 8 is negative 12. Then we keep going. A sub 2. A sub 2 minus 1 minus 8. 2 minus 1 is 1. A sub 1 we just did was negative 12. So we have negative 12 minus 8, which is negative 20. A sub 3, so plug in a 3 anywhere there's an n. A sub 3 minus 1 minus 8. 3 minus 1 is 2. A sub 2 was negative 20, so we have negative 20 minus 8 is negative 28. Now that was a sub 3, but how many terms was that? We did 1, 2, 3, that was the 4th term, so we only need one more. So a sub 4 minus 1 minus 8, 4 minus 1 is 3. A sub 3 we just did. So it's negative 28 minus 8 is negative 36. Okay, so that's writing out our terms for our recursive. Now, the next part, write the explicit and the recursive. So they want both rules. Number 27, first thing, in order to write these out is I have to know what they are. Is this geometric or arithmetic, and how do you know? This is an A sub 1 and it has a D. What does D stand for? Difference. So this is arithmetic. So if this is arithmetic, we have two equations. We have our explicit, which is A sub n equals A sub 1 plus n minus 1 times D. And we have our recursive, which is A sub n equals A sub n minus 1 plus D. Those are your two equations that you have. So we're plugging in what we know. Okay, so first for our explicit, what do we need? A sub 1 and D, which we have. So plug in your 3 and your 10. And solve, just like you did the other day. So this gives us 10n minus 10. So what's our explicit? Our explicit is 10n minus 7. Then your recursive. Remember, your recursive is multiple equations, so you have to give yourself somewhere to start. So we start right here. We start on a sub 1 equals 3. And then the recursive we plug in to get the second part of our equation. So the second part of our equation is right here. A sub n minus 1 plus, what's D? D is 10. So you got to make sure on the recursive, you got to give yourself your position where you start. A sub 1 equals 3. And then everything after that, A sub n equals A sub n minus 1 plus 10. Okay, the next one we're going to look at, 31. Arithmetic or geometric, and how do you know? It has an R. R stands for ratio, so this is geometric. Okay, and our two rules, explicit for geometric, A sub n equals A sub 1 times R to a power of n minus 1. And the recursive, A sub n equals R times A sub n minus 1. Okay, so the explicit. All we need is A sub 1 is R and R, which we have, so plug them in. So our explicit is 5 times 2.5 to a power of n minus 1. And then our recursive. Remember, always define your starting point. So that's our first equation for our recursive, A sub 1 equals 5. And then everything after that comes from here. So 2.5 is my R times A sub n minus 1. Now, three more easy ones. Write the recursive rules. So all we want is recursive here. Okay, well, first thing is you have to figure out what it is. 35, is it arithmetic, geometric, or neither? What do we have? Plus 6, plus 6, plus 6. So if we're adding 6 every single time, 35 is arithmetic. Okay, and if I were to ask you, what would it be? D would be 6. We're adding 6 every single time. So we have arithmetic. So all we're doing is plugging in. All it wants is recursive. Okay, so what's our recursive? Where do we start? Remember, always define where you start. So A sub 1 equals 1. And then to get our recursive, it's just A sub n equals A sub n minus 1 plus 6. 38 plus 5 plus not 5. So it's not arithmetic. So how about geometric? Divide. 8 divided by 3, 63 divided by 8, 3,968 divided by 63. Is there a common ratio? Nope. So 38 is neither. So you have to find the pattern. If it's not arithmetic or geometric, you have to find the pattern. So what's the pattern here? How can I get from 3 to 8 to 63 to 3968? Does anyone see it? What's 3 squared? What's 8 squared? What's 63 squared? Does anyone see it yet? 3 squared is 9. And then how would I get from 9 to 8? Subtract 1. 8 squared is 64. How would I get to 63? Subtract 1. 63 squared is 3,969. Subtract 1. You get 68. So your pattern is you have to square and subtract 1. So we start at 3. A sub 1 is 3. And then our pattern is we have to square the previous term. So a sub n minus 1 squared. You square the term beforehand and subtract 1. Okay, so if it's not arithmetic or geometric, you got to find the pattern and then fill in your a sub n. 41 plus 3 plus 5 plus 40. Not arithmetic. Well, how about geometric? 5 divided by 2. 10 divided by 5. 50 divided by 10. Are those consistent? 5 divided by 2, you can't reduce. 10 divided by 5 is 2. 50 divided by 10 is 5. Nope. So this one is neither. So you need to find the pattern. Does anyone see the pattern yet? Pattern comes from the two terms in the beginning. 2 times 5 is 10. 5 times 10 is 50. 10 times 50 is 500. So if it comes from the two terms, we have to define these two. So a sub 1 is 2. A sub 2 is 5. And then what did we say? We're multiplying the two terms beforehand. So a sub 1 is 2. A sub 2 is 5. And then we are multiplying the two terms before. So that's a sub n minus 2 and a sub n minus 1. Okay, notes were a little bit longer today, but it was a little bit more in depth. So I hope you enjoyed the lesson. I'm going to write your homework down here on the bottom. We have 3 through 7 odd. And then you have 13 through 21 all and number 38.